See, when we visit Karlsruhe, the city of innovations, we cannot go without introducing you to a new innovation. Thanks to Josef Stefen, we are able to find out an innovation which can help the metal industry. Josef Stefen works with Impact Labs, and he is going to tell us about a new non-destructive testing equipment which can bring a lot of solutions for the challenges faced by the people who are in the heat treatment, people who are manufacturing metals. And Joseph, welcome to Machine Maker.
Thank you. Nice to talk to you.
Let's first talk about yourself. So where you are from, about Impact Labs.
Yeah, my name is Josef. I'm plain German, grown up in Ingolstadt, where Audi is located. So automotive is in my heart, you know.
Okay.
And that was also why I took then mechanical engineering as my professional education. I went to automation and worked many years then in the automotive industries. Then later on I moved in pharmaceutical industries, but it was always the same header: sensors, data, innovation.
You found Impact Labs?
We found Impact Labs together as a small team because we need different competences, but I'm one of the co-founders.
Okay, so what is that innovation, what you are going to talk to us, and what made you to innovate that?
We talk about today about our new DFA sensor, which is a more advanced kind of eddy current testing. More advanced means everybody can use it. It's not so difficult to handle. You don't have to spend a lot of time to set it up. You just use it. Use it for the metal industry then.
So why you innovated it?
We innovated it because this technical principle, what we use, is an ideal thing for sensoring metal or all conductive materials. But we found limits on the existing technology used, and there we thought we put a little more effort in order to really give progress and application for industry.
So which are the industries which can get this applied? Which are the major industries?
The major industries are all metal processing industries. Of course, we start with automotive, where my heart beats for, but also for aerospace or other chemical industry areas. We, of course, will sooner or later offer a sensor layer.
So Joseph, his heart always beats for automotive. He is from the land of Audi.
The major challenge, what you face normally on shop floor is if you have mass production and you want to ensure that your process was processed right and the right way, then you sometimes have mix-ups. So you don't know if a part was treated or processed in the right way. That of course gives you a headache later on because mainly those parts go in higher value products like gearboxes. And what do you do then? Do you scrap the gearbox or do you test the device? But so far, non-destructive testing is not so common in this area. The technology was not ready and right for
the big gearboxes.
Big gearboxes or everything which is safety relevant or has a higher value within a car, for example, like the steering wheel. If those kinds of parts fail, then of course you get in big trouble. And this is what we took as a challenge. And there we started to put a hardware control into a new kind of excitation for eddy current. And this is what we use right now in order to distinguish them between materials, but also the metal structure of the materials. And it's perfect for industry use because this hardware control gives you the possibility that you don't need an expert. You give a small application on the device and everybody can start immediately to, for example, sort parts. And so ensures 100% quality then.
Okay. So we will have a small demonstration of the product right now. But let me tell you that he was talking about a big gearbox to be tested, and I am seeing a very small pen-like objects, just in front of us. So can we go ahead and look at the product?
The product is in principle an inductive sensor with a sensor head, and that's also one of the novelties. We have a relatively small sensor head.
Oh, this is the sensor head.
That is the sensor head, that's the tip. And with this tip, we have a coil inside the tip, and there we can do point measurements. but also line measurements, or we can scan areas then.
Okay, but this is from where the sensing is done.
This is from where the sensing is done. This is also customizable. So if you have smaller parts, then you have, for example, a smaller sensor head. If you want to measure larger areas, then you use a larger sensor head.
Oh, so it is customizable, or it comes with different parts, sensors.
It's customizable for the application because you can use it as a handheld and do general measurements. But the real idea behind is also to use it later on in machinery, in process. So use it as a kind of IoT.
So any metal processing, this small products can bring wonders when it comes to testing quality, and there is a chance that you can save a lot of money by not having the traditional process where so many people are involved, so much time is involved, and this is just tada.
Right.
Am I right?
Right, because in many cases with high value parts, you don't want to touch the product even, you don't want to scratch it, you don't want to put an imprint on the part because it's simply not possible to use it then later on. So it's a destructive testing. Here we can measure also in distance. We can measure without any destruction of the material as such then. And this gives a huge advantage to the user then.
True. So shall I handle this if you want to show how it works?
So this is a real use case. We had to separate and distinguish between those two parts. One of them is hardened, the other one is not hardened. And the difference is not so huge. And we had in principle no time to set up the sensor. So we developed a menu here, a small setup, which is called quality control, where you just learn on one part by measuring numerous times. So the device learns about the characteristic of this material, and if you then later on measure against this reference part, you get green or red depending on what kind of parts you have in front of you then.
Just a second. It's just a second.
It's no time.
It's no time, and it is not a big, difficult task for anyone to do it. Any student can come and just do it and check it.
It's a typical A to B testing, so you test against the reference, so everybody can teach the device and everybody can use the device, and which gives a huge advantage in the field then.
I'm sure that this product can find a lot of opportunities in India, applications in India, and how we will be able to. I think I can just take this in my bag and go, and so light. Otherwise, how the Indian companies can get hold of this?
So right now we offer this handheld device to start with. Most of the companies want to start with trials, want to learn in the laboratory how this thing works, because it's a kind of new way to look at materials. But of course, we are also on the way to minimize the product.
Oh, more cute and more small?
Smaller, to put it into machinery, to measure in the process every part at any time. This is our mission.
Thank you very much. And people can contact you and try to. You are selling this in India, right?
We are selling this in India, we are selling this worldwide.
Okay. So friends, I'm very happy to bring you this very small sensor for all metal processing, which can ease your life, and in no time you can save a lot of money, lot of time, lot of manpower. And the world is going towards automation and these kind of innovations. That is what Karlsruhe as a city is famous for, innovating new products. And I'm very happy to talking with Joseph, and thanks for your kind time sharing about this product.
Thank you too, Harry.
And I wish you all the very best for making this popular.
Thank you.